So with all of the reviews that I've been doing lately, I wanted to break out a video separate from the reviews to kind of highlight what is going on with the tiller bolts and the interface with the limbs and how those two interact and how important it is to you as an archer. So with all the reviews of all the new gear that's coming out that I've been doing on the channel, I've been doing a lot of talking during the reviews about the fitment or the interface of the fork of the limb, the butt, where it snaps into the bow and interacts with the tiller bolt. I've had to explain during all the reviews why it's important, and I figured instead of cluttering up my reviews and making them much longer than they need to be, they're approaching 55 minutes now, so I really want to try to shorten those up some. I wanted to break out the explanation of why the fitment of the fork of the limb, the base down here, and how it snaps and interfaces with the tiller bolt and why that's important. And I figured I better just do a separate video that I can reference of my future reviews that I'm going to be doing. So that way it's shorter for you, the viewer, and that way it's a little bit more I guess clean, so that way there's just less chaos going on during the reviews. So forgive me if you've seen this information already, but it is super, super important, and I didn't realize how critically important this part of the bow, where the two of them snap together down here at the tiller bolt, I didn't realize how important that was until just a short bit of time ago, relatively speaking. You know, about 4 years ago or so, I started to realize how important that was. And I wish I would have known this much earlier in my career when I was competing, because how this fits or how it doesn't fit can really affect the actual grouping and performance that you see downrange, especially at the Olympic distance, 70 meters. So one of the main things that I do in my review videos to test and see how these things fit together is not just how does it snap together, but I take the limb, I turn it backwards, I don't engage the dovetail with the actual riser, and then I slide the riser, or the limb rather, into the tiller bolt in place like this, and then I take the bow and I tip it upside down. And if the limb stays in place without shaking it, it's good enough. But when I can shake it like this and it still doesn't fall out, that's a good bonus, because what that's showing me is the ID of this slot is matching well with the OD of the shank of the tiller bolt. Now, why that in particular is important, and I'm not talking about the dovetail fitment or the consistency or size of the actual dovetail down inside of here, is because of the way the actual bow, the limb and riser works together. So when the limb is snapped in place like this, and when you have the bow strung, there's forces of the limb actually pushing inwards against the riser. It's also pivoting back this direction because the limb's bending, of course, but there's a lot of force going in. Because there's force going in, the dovetail, this part here on the limb right here, that silver piece, it's round. Even if this is inconsistent and this interface down here is inconsistent, there's a round receiver and a round receiver. When they're being pushed together, they self-center. So they always align to the center, even if there's play, even if there's slop. Because as it's being pushed in, it's also being pulled back. The back of the limb is pushing flat against where it sits against the riser or the adjuster. And so because it's flat and it's being pushed in, it's always going to be centered pretty much in the exact same place every single time, even if the interface there or the consistency is off. Like say if this is too small and this is too big, doesn't matter. Because they're both round, they both are going to center themselves down at the very bottom because of the forces that are holding the bow together with, right? So the other side actually floats a little bit. It's not jammed all the way in to where the inside of this round section pushes against the round section of the tiller bolt. It doesn't do that because there's inconsistencies in ILF, International Limb Fit Standards, as well as inconsistencies in formula bows. I'm pointing over there because I've got formula bows in the cabinet. That interface there is not all the way down. It actually floats because as you adjust the draw weight, the limb actually pivots and moves away from the bolt and pivots and moves towards it as you go in with it, right? So because that happens, it has to float. So what's more important is the actual parallel sides here, the flat sides, and how it holds the actual tiller bolt itself. And so like I said, if this happens, it's good. That means the tolerance is great, it works, and it's going to be just fine, and there's not going to be any problem. But when something like this happens, where I take this limb, snaps in really nice, comes out really nice, but when I turn it backwards, put it in place, and then tip the limb and the bow like this, it will fall right out without even shaking it, because the interface here, down at the bottom of the limb where it interacts with the tiller bolt, it's too big. And I can actually feel on this one play from side to side. So if I try to isolate it, I'm moving the limb up and down. That click, click, click is actually showing me that I've got play there in the actual fork of the limb against the tiller bolt. Now, may not seem like a big deal, and most people will take their limb, put it in, and if it comes out real easy, they like the convenience of that. That is part of the ILF fitment and why it's nice. And I do agree, it is nice when it comes apart really well and easy, because sometimes these limbs are a little difficult to get out, and if you don't know how to properly take limbs out of a riser, you know, you can sit there with two grown men playing tug of war and the thing won't come apart. But all you need to do is simply grab the limb here with your thumb and then press against the riser and pull at the same time, and it comes out very, very easily. So to give you a kind of exploded parts view, this is a tiller bolt here, and it goes into the fork of the limb like this, right? So as it's getting assembled, it slides into place just like that, where it goes in, and then it sits there and presses against the actual face of the limb. So the tolerance that I'm talking about, or the play that I'm talking about, is actually, it's like I said, not in and out, it's left and right. So left and right. And I'm clicking the bolt back and forth like that. And so you can hear the actual tolerance play. So the forces are holding the limb down and in and against the tiller bolt. So it's pressing against the tiller bolt, pressing against the riser, being pushed in. That centers the ILF, but the fork has room for play left and right. And if you have room for play between these two spots, because everything pivots on this, remember it's all self-centered, and then the play out here will allow the limb to shift left and right, which makes the limb tip shift left and right. I have a video I've already made about the debut of the Kaminski Archery Precision Tiller Bolts. These are right here, which are available on my website, jkaminski.com. I will have links in the description below and a card at the top up there. But during the launch video of the Precision Tiller Bolts, I showed how much of a difference a set of limbs and a riser that had play, how much of a difference it actually makes. And I displayed not only the actual alignment of the limbs shifting depending on how the limbs are installed to bow, whether it's play this way or take up the play that way. You can actually see the alignment on biter blocks changing. And when you shoot at 70 meters, the Olympic distance, and you shoot with them this way and then shoot with them this way, the group actually shifts downrange on the target more than a foot. Now this was with about 0.08 of an inch play, if I remember correctly. That means that the inside diameter of the limb was 0.08 of an inch, 0.008 inches bigger than the tiller bolt was, the OD of the tiller bolt. That kind of play is ridiculous because it's really directly affecting how the arrows group downrange and how consistently your arrows may group. Now, if your bow is perfect, in a perfect world, in a perfect environment, and you never bumped it, you always picked it up the exact same way, you always strung it the exact same way, you always handled the bow exactly the same every single time, and you didn't accidentally bump it up against somebody as you're walking by. You didn't accidentally get distracted when somebody was asking to see something that you're working on while you're snapping your limbs in, or stringing your bow, or doing something different, or someone else strings your bow. The consistency of how the limbs get installed into the bow is going to be really, really important to your consistency and your accuracy and your grouping downrange. So the way to actually check your interface, if you don't want to just turn your limbs around backwards and see if they fall out, is you can actually use a set of calipers. And so if I measure the inside diameter of these WeaWiz limbs here, they're 373 thousandths of an inch inside diameter. And it can change depending on where you measure it. So in slightly different places, you get slightly different measurements. Really, the smallest measurement is what you want to see, because if I have these misaligned, not perpendicular to the flat surfaces, the number gets bigger than if it was parallel, or perpendicular rather. So the smallest number that I can see here is 373 thousandths of an inch, give or take. So that's the inside diameter here. And what I'm going to do is measure a couple of tiller bolts that I've got behind me. 373, this is a win-and-win tiller bolt. I got a Hoyt tiller bolt here, 372.5 thousandths of an inch. I've got another win-and-win tiller bolt, 372.5 thousandths of an inch. And so there's variations of another win-and-win, 373. And there's variations from tiller bolt to tiller bolt. Some are smaller than others, some are bigger than others. Here's a Hoyt, one of the pivoting Hoyt tiller bolts. That's a prototype that I've got, 371.5 thousandths of an inch. So you can see that there's variance in the tiller bolt. Now, this limb was 373, the win-and-win. If I grab the Sebastian Flute Neutron, which I reviewed recently, if you're interested in that, check out the links in the description. This is 380 plus at the big end, the big opening of the limb. So when you take a tiller bolt, that's 373 thousandths, that's what this win-and-win was, and I tip it upside down, the tiller bolt just falls right out of the limb. Same thing goes with this other win-and-win tiller bolt. They just fall right out. Now, what happens when you insert and play with what we've got here, these Kaminski Archery Precision Tiller Bolts? The silver one here is 375, and the black one here is 380. So what those numbers are calling out is the outside diameter of the shank, and you'll see that this one's 379 thousandths of an inch, right? Because what our specs are is a maximum of 380 thousandths and a minimum of 379 thousandths. So we have a plus or minus of a half a thousandth of an inch tolerance when we have these machined. And if I zero again, just so you can see it, and I grab this 375, you'll see that it's 374.5 thousandths of an inch. So the tolerance on ours from tiller bolt to tiller bolt is very consistent, and we have the option of oversizing to 380 thousandths. So the ILF standard for the outside diameter of the tiller bolt shank is 375 thousandths of an inch. So it should be that. However, there is no spec called out as far as the tolerance. What is the minimum and what is the maximum? And because of that, the industry, the archery industry as a whole, is really widely variant. Some are really, really small, really down towards the 370 thousandths of an inch, and all the way up to 380 plus thousandths of an inch. That goes for both limbs and tiller bolts. They're not consistent across the board. But because we have the ability to offer you a standard size as well as an oversized, you can take the standard size tiller bolt and you'll see that it'll fall out of this Sebastian Flute limb. But when you take the 380 thousandths of an inch black one we've got here, push it into the limb, it stays in place because the tolerances actually match. We oversized the tiller bolt specifically for this reason, to take up too large of a limb fork where it's actually just outside of tolerance spec in our opinion. Because there's no actual standard spec and limits of the ILF standard as far as the size of the fork, when I say it's out of spec, not really, because it's not actually listed, but for what I would consider tolerances, this is definitely way out of spec, because it's really, really easy to maintain the tolerance that we're maintaining on our tiller bolts. It's actually a standard machining size tolerance for the size given of the outside diameter of this shank. It's nothing special. It's not actually precision machined. Precision machined is way tighter tolerances, talking microns, instead of talking about thousandths of an inch. And that's just not what we're doing. We use standard machining practices and principles to maintain these tolerances. And so when I say it's out of spec, it should be much better. But I think as a whole, the industry just doesn't understand that this is important. number one. I don't think they actually realize how important this is. And number two, they aren't maintaining the specs anyway, so everything's all over the place. And this doesn't just knock on the Sebastian Flute limbs for being too big. You know, actually these win and wins are a little bit smaller than they should be. They're 373 thousandths. Could be due to the paint that's on the inside and easily removable to make them 375. But those Sebastian Flute being well over 380, to get them back down undersized where they should be, not undersized, but to the size they should be, it's not possible. You can't really add material back. You could add clear coat and paint, but it wears, it comes off. You could add shims, but again, that's not the point. The point is it should fit better. And we have that solution through Kaminski Archery with precision tiller bolts. And instead of cluttering up the reviews that I do with this information and this length of time that I'm taking to explain it, like I said, I just wanted to break it out and show you why this is important. Now, like I said, before I got sidetracked, this is not a knock on the Sebastian Flute limbs. Again, it's a spec that no one really knows about, and I've seen just about every single limb manufacturer out there have a limb that is bigger than 375 thousandths of an inch, which is supposed to be the ILF spec standards. I've seen Hoyt's oversized, I've seen Win and Wins, I've seen WNS, I've seen Sebastian Flute oversized. I have not seen Uka's oversized, but I have seen a lot of Uka's undersized to the point of where people are having a hard time getting the limbs in and out of bows. Again, it has to do with specs, and because the ILF standard, when it was originally formed back in the day, like I think it's in the 80s, I think. It was quite some time ago. Maybe it was in the 70s or even before that. Forgive me for not knowing my archery knowledge. If somebody knows, comment below and let me know. I'm sure you can look up the patent for the ILF standard. Sorry, I'm going on and on and on. It's something that is very bothersome to me, and I'm very passionate about it because when I was shooting, I had no idea. Shooting meaning competing at the Olympic Games. I had no idea. I can't tell you how many times I took my bow, unstrung it to change the brace height because it was off, and strung it back up again. And I don't know where my arrow went. Probably not in the middle, because when you snap the limbs in, they can be misaligned ever so slightly to the riser. And that little bit of alignment change dramatically affects the trajectory of the arrow. The reason being is if the limb is off this way, it's now changed my string over here, which has actually changed my center shot, which changes the trajectory of the arrow, the forces that are being exerted on the arrow, and then the arrow deviates as it goes downrange from its path and results in a less than ideal result. So it is a thing that in the back of my mind, it's like, man, what if I knew? What if I paid attention to this? What if precision tiller bolts were available then, or I could have them made then? I don't know. There's a lot of what ifs that are possible, and I'm excited that I found this information out because I can share it with you ultimately so you can actually avoid this problem in your future as well. Like I said, the first thing that I think is, man, these limbs are very easy to come in and out of the riser, to install and take out of the riser, and I like that. I don't have to spend excess energy to rip them out of place and deal with that hassle. But now I wish that things were a little bit tighter, because I probably would have shot a little bit better as well. So, like I said, I just wanted to share this with you. I wanted to break it out into a standalone video because the review videos are getting very, very lengthy, and I wanted to kind of break out a couple of sections when they seem to be consistent, so that way you can understand better. I can reference this video in the review videos so you can see it and get a little bit more in-depth information as to why and how and different variants that I'm seeing here, and I can take the time to explain it to you without having to hurry up because it's a review video. So I hope that's okay. I hope you didn't mind this video. And if this is the first time that you're seeing and hearing about these precision tiller bolts from Kaminski Archery, I will have links in the description below to where you can get these at jakekaminski.com as well as kaminskiarchery.com. Both those links take you to the same places. I'll also have a card at the top up there again. And they are available for Hoyt and Win and Win and Sebastian Flute risers. Right now, that's all the support we're offering for precision tiller bolts. There's so many different designs out there of various different threads and lengths and all sorts of different things. And we will eventually expand our lineup of precision tiller bolts. If you'd like to see your riser supported, comment down in the comment section below and let us know. They are available in both stainless steel and black. The black is still stainless steel, it's just nitride coated. Both available at the USA location as well as the Europe location and a few different other places as well around the world. I can't thank you guys enough for getting these on your bows and rocking them out there. It's really cool to see so many of them at Lancaster this year at the Classic.